Okay, good day to each and every one of you. Let us now proceed to Module 2 of Quantity Surveying, which will be focused mainly on Masonry. So Masonry, the word Masonry is often thrown around but not always fully understood. So probably you already have heard this many times before, or at the present, but we really do not understand the meaning of Masonry. A masonry structure includes anything built by fusing together materials with the help of mortar as an adhesive. Okay, so what do we call the workers that do masonry works? They are called masons. They are not called carpenters. Okay, we also have classifications of your masonry. We have two types of masonry, which is veneer masonry. Okay, what is veneer masonry? It is usually put to use for aesthetic purposes as opposed to creating a sturdy structure. So the term or the thing that we really need to understand in veneer masonry is that it is used for aesthetic purposes. Okay, it includes tile setting and stone wall design. How about solid masonry? Solid masonry can hold itself up and fight off the elements. It includes hollow block laying and bricklaying and etc. Many more. Okay, let us go back to the pictures that I have shown you a while ago. So this is considered as, this stone wall design here is considered as veneer. And we also have tile setting. Okay, this is also a veneer masonry. How about this bricklaying here? Do we consider this as a veneer or solid masonry? We can consider this as veneer masonry because the purpose of the bricks here are just for their appearance as a brick or just for beautification. So this is not a solid masonry. How about this solid block laying? Obviously, this is solid masonry. Okay. Concrete hollow blocks. So what are concrete hollow blocks? It is popularly known as CHB, and it is classified as load-bearing and non-bearing blocks. Load-bearing blocks are those thickness ranges from 15 to 20 centimeters, or if we convert this to metric or to inches, I should say, 15 centimeters is 6 inches, and 20 centimeters, okay, is 8 inches. So these are really thick hollow blocks and are used to carry load aside from its own weight. So normally we use this in the interior of our houses, which are installed below the beams. It helps the beam in carrying loads that are installed on top of it. And we also have non-bearing blocks. On the other hand, or blocks intended for walls, okay, partitions, fences, and dividers, and like carrying its own weight only. Okay, there are no really structures um, that are installed above it. Okay, the only weight that it's carrying is its own weight, whose thickness ranges from 7 to 10 centimeters, or we can convert that to inches, which will be 3 to 4 inches. So why are we converting it to metric? Okay, because the purpose of converting it to metric is for the purpose of computation, or to computation and estimate. Okay, the standard hollow block has 3 void cells and 2 half cells at both ends, having a total of 4. So we also consider this as half cells. Okay, therefore, if we put them together, it will still make one whole cell. These hollow cells vary in sizes as there are different manufacturers using different types of mold. Cement mortar, or we can simply call it mortar. It is a mixture of cement, sand, and water. It is used as bonding materials in installing masonry blocks and other various plastering work. Okay, here are the items that we should consider in estimating cement mortar. The mortar to be used in between the layer of the CHB. So this mortar in between the layers we should also consider in estimating. Okay, the mortar filler for hollow core or cell of the blocks. So obviously we will also consider the filler, okay, that we put inside the cells of the hollow blocks. This filler could be pure mortar or mortar with gravel for economy. Okay, so as you can see here, mortar with gravel, that will now be obviously a mixture or a concrete mixture. But I think we cannot yet consider it as concrete because the concentration of or the amount of cement that is put to this mixture is not that enough to be considered as concrete. We should also consider the fine screened sand for plastering. Plastering, we also call this palitada or rebocada. This is a pasty composition that is used for coating walls, ceilings, and partitions. They consider this as the cosmetic of the walls. So we have two types of plaster, which will be mortar mixture only, or we call that rough plaster, and fine plaster. So in fine plaster, it is just a grout mixture of cement and water, or we also term this as puro, to have a smooth surface after application. So I will now explain to you, okay, the basis of estimating the materials that is needed for masonry works. So we also have class A, class B, and class C type of mortar. So this is also made for every cubic meter of mortar. So this is made for 1 cubic meter of mortar. So in 1 cubic meter of mortar using class B, you will need 12 bags of cement in 1 cubic meter of sand. So the quantity of the sand will be equal to the quantity of the whole mortar. Let us also discuss the specifications of a 4-celled CHB. So the standard CHB has an 8-inch by 16-inch dimension. So the height is 8-inch and the length is 16 inches. And this thickness here varies from 4 inches to 6 inches depending on the purpose of the installation of these hollow blocks. Okay, we also have here a factor which is 12.5 pieces per square meter. This is also an important factor for you to remember because this is the basis of estimating the number of hollow blocks which should be installed. So how did they get this 12.5 pieces per square meter? They simply divided 1 square meter with the area of the face of the hollow block, which is 0.2 multiplied by 0.4. So that will now be 12.5 pieces per square meter. So maybe you already forgot the factor of how many pieces per square meter, and then what you remembered is the dimensions of the hollow blocks. You will simply divide with its area. But what they are usually doing in estimating the number of pieces of hollow blocks is that they add additional, or they add 10% of the total amount of hollow blocks, or from the computed number of pieces of hollow blocks, you will just multiply 1.1 in case of breakage of hollow blocks. So these are also important details in estimating the mortar for hollow blocks. We have CHB fill and block laying. So if you are using 6 inches hollow block, so the amount of fill that you are putting inside of the cell of the hollow blocks will be 0.006 cubic meters, plus the block laying, which is the mortar that you are using here, that will now be 0.008 if you are using 6-inch hollow block. Okay, so for simplification purposes, the total amount that you will use per hollow block, if you are using 4 inches, that will now be 0.00, okay, 0035 cubic meters. Okay, that will now be for 4 inches. How about in 6 inches? You will just add this up. That will now be 0.0068 cubic meters. Okay, let's go now to a problem and try to apply the estimate that we have discussed. Given a partial CHB wall, compute the masonry materials needed. Okay, we have 6 meters on center and 5.5 meters on center. Again, this denotes on center, and this is from the center of the column to column. Okay, the height is 2.8 meters. And we also have the dimensions of the door and the window. And the area of the door and the window will be deducted to the total area of the application of your masonry work. And we are using 4 inches thick CHP. Okay, so we should remember all of this details. We have a column 0.4 by 0.4, and that will be all for the computation. Now, first, we will compute the area of the wall. So the area of the wall will now be 5.6 plus 5.1. Remember this solution right here. Okay, the thickness of the column is 0.4. That is why you should deduct 0.2 plus 0.2, or that will simply be the thickness or the width of the wall. And same as true with the other side, 5.5, okay, that is 5.5 on center minus the width of the column. The width of the column is 0.4. That is why that will now be 5.1 meters. Okay, and then the height. Okay, and we will just deduct the area of this. So the area of the wall, so this is just the area of one face of the wall. Remember, there are 2 faces of the wall. This will be the interior and the exterior, but we will only consider one face. So this will now be 5.6 plus 5.1 multiplied by 2.8. Okay, why did we add 5.6 plus 5.1? Okay, we just considered that this is a whole, or this is the whole length of your wall. 5.1 plus 5.6. Or you can also compute this separately if you are confused with this kind of solution. Okay, but we will just consider them as a whole. So we will multiply that by height. So this is length times the height of 2.8 meters, minus the area of the door, which is 0.8 multiplied by 2.1 minus 0.4 multiplied by 1.2. Okay, so this will now be the total area, 27.8 square meters. So the number of CHP that will be installed to make this wall is simply the area multiplied by the factor. So that will now be 27.8 square meters times 12.5 pieces per square meters. That will now be 348 pieces of CHP. But if you want to add a safety factor, you will simply add how many? What is the 10% of 348? That will now be rounded off to 35. Okay, so what is the amount of CHB? That should now be 383 pieces. Okay, so let's go now to the estimation of the cement mortar. Now, the volume of cement mortar will be the number of CHB times the CHB fill plus the block laying. Okay, those are the factors that we are discussing a while ago. That will now be 348 pieces times 0.003 cubic meters plus 0.005, or you can simply put that 348 pieces times 0.0035. So that will now have a total volume of 1.218 cubic meters of mortar. If you want to use Class B cement mortar mixture, okay, from the table that I was discussing a while ago, that will now consider 12 bags of cement and 1 cubic meter of sand. So that will now be 12 bags of cement. We will multiply the volume to 12 bags of cement. So this will now require 15 bags of cement. Okay, so the volume of sand. So the volume of sand will be 1 cubic meter per cubic meter of concrete. So this will just be multiplied by 1. So you are also required to prepare 1.5 cubic meters of sand. And the volume of water, we will use the same factor, 6 gallons per bag. So in every bag, we will use 6 gallons. We can also compute for the amount of plaster that will be used in the face of a hollow block. So the average thickness of plaster is 3/4 inch. So if you convert that to millimeters, that is 19 millimeters or 0.019 meters. Therefore, the volume of rough plaster per hollow block, per face of a hollow block, is 0.2 times 0.4. Okay, remember, this is the area of a hollow block. 0.2 by 0.4 multiplied by the thickness of the mortar or the plaster, which is 0.019. Okay, we can multiply that and we'll have a factor of 0.00152 cubic meters of plaster considering one phase of CHB. So you can simply compute the amount of plaster by multiplying the number of hollow blocks into this factor 0.0152. So if you are going to compute the amount of plaster in the wall, you will just multiply the number of pieces of hollow blocks multiplied by 0.00152 cubic meters multiplied by 2, okay, because we are applying it to the two faces of the hollow blocks. That will now be equal to 1.015792 cubic meters of mortar. We also have method B that will now be based on the area. I think there will not be much of a difference because the number of CHB is also based on the area to be plastered. So you can use method A or method B. Using class B cement mortar mixture also for your plaster, this will now be 1.05792 cubic meters, okay, of mortar for used for plastering multiplied by 12 bags. Again, we are using class B, that's why we are using 12 bags. Okay, that will now be per cubic meter. That will now be equals 12.69 or 12.7 bags of cement. So we can also round that up to 13 bags of cement. So what is the amount of sand that will be required to make this? So simply the amount in cubic meters multiplied by 1, that will also be 1.05792. But this is wrong. This should not be 1.5 because that is a large amount. This should be equated to 1.06 cubic meters of sand. We also have a volume of water that will just be multiplied by 6. So we will need 78 gallons of water. We also have here a factor in estimating the number or the amount of cement that you will use in fine plaster. So this will now be what is so-called puro. The factor is 2 kilograms per meter square or 1/20th or 1/20th or 1 over 20. Okay, that will also be converted to 0.05 bag per square meter. Okay, so the number of cement will simply be the area to be plastered, which we already have computed a while ago, times the factor, which is 0.05 or 1/20th, times 2. Okay, this denotes the two faces of the wall or the area to be plastered. That will now be 2.78 bags of cement, or we can round that up to 3 bags of cement. And of course, we also consider the volume of water that will be used in plaster. So the volume of water will now be 6 gallons of water multiplied by 3 bags of cement. That will now be equal to 18 gallons.